All right, let's cover rate of change. Rate of change, which is the m in our function. So if I have f of x is equal to b plus mx, this is my rate of change. And it's also called a slope. It could be positive if it's increasing. It could be negative, which is when it's decreasing, or it could just not be there at all, which means it's constant, okay? Rate of change is equal to slope. The rate of change of a linear function is also called the slope of the line, and it's represented by m. M could be positive if it's increasing, negative if it's decreasing, or it just wouldn't be there if it's constant. All right, so here's a way to find your rate of change or your slope. You have to have 2 points. That's it. If I have 2 points, so point 1 and point 2, and I like to do it like this. Point 1 would be, well, every point has an x and a y, right? Every stinking point has an x and a y. But in this regards, point 1 would be x sub 1, y sub 1, and point 2 would be x sub 2, y sub 2. Don't freak out on that. It's just labeling what they are. Okay, so now we can use a formula. It's the change in the output. So the rate of change is equal to the change in the output, which is y sub 2 minus y sub 1, divided by the change of the input, which is x sub 2 minus x sub 1. We're going to use that. I'm going to show you some examples now. All right, we have to pull out the information for what our points are at this point. So we're going to have a point 1 and a point 2. It doesn't matter which one you choose for either one of these. Okay. One of the things I am going to tell you, however, just to help you out here so you're not wondering which one is in our x position and which one's in our y position. Anytime you're given a time, years, months, days, whatever it is, that is always, always, always your x value. Okay, so remember, for a point, it's x and y. So your first value is always going to be time. So our first one would be 2002. I guess I should read this first. The population of a city increased from 23,400 to 27,800 between 2002 and 2006. 2006, there's my times. All right, now you have to find out which one's related to the output. And the output for this is the 23,400 and the 27,800. Well, which one came first? This one did. And which time came first? This one did. So these two go together. In 2002, the population was 23,400. Okay, which means the second one is equal to, is a function of 2006. So in 2006, what was the population? The population was 27,800. Okay, you have to do this first. If you don't, you're going to end up messing up somewhere. You're going to find the rate of change of the population during this time span. So between 2002 and 2006, what's our rate of change? How did the population grow or decline? So did it increase or did it decrease? And they're already telling us it increased. So a little tip, if it increased, that means our rate of change should be positive. No, our rate of change will be positive. If you get a rate of change that is not positive, it is wrong. That should be a huge, red flag for you. If you see that the population is increasing and you get a negative slope, a negative rate of change, it's wrong. Okay, so let's plug it into our formula now. Our rate of change is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I always, whether you're here or not, label x sub 1, y sub 1, x sub 2, y sub 2. So our rate of change, y sub 2 is 27,800 minus 23,400 divided by, here's where a lot of mistakes happen. People flip which one they do first, and this is what will get you in trouble. Please be careful. If you start with, and this is why I label them, I'm calling this one 0.2. So I have to start, since I started with this one, I have to start with its input value of 2006, which is x sub 2, minus x sub 1, which is 2002. If I had not done that, I would have got a negative answer, and that wouldn't have been good. All right, so let's keep going. What is our rate of change? Well, let me come over here and subtract this real quick. 27, oh, I know what this is. It's 4,400. 4,400 divided by 4 years. So that means, and I can stop right here for just a second and say, every 4 years, the population is increasing by 4,400. We're not currently in a unit number because we don't have a denominator of 1 yet, which is what we're going to take it to. We have to divide by 4 to get our answer. And our answer would be 4,400 divided by 4 is 1,100. Great. What the heck does this mean? Well, it's currently over 1, right? Everything, if it's just a whole number, is over 1. So I can say the rate of change is the population increased. Use the words increasing or decreasing. I promise you it's so much easier. Population increased or is increasing by 1,100 every year. There's the time element. And that would be my answer. Okay, they're wanting to know what happened during that time span. So during that time span, the population increased by 1,100 every stinking year. Okay, your turn. I'm going to give you the function, the slope formula. So given 0.1 and 0.2, but you have to figure out what those are. You're going to have the rate of change is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. All right, pause the video and attempt this on your own before you come back and watch how I do it. Okay. In the year 1998, the surface elevation of Lake Powell was, so our input is 1998. I'm just going to plug that in here. 1998, what happened? What was the output? 3,843 feet above sea level. So 3,843. Okay. In the year 2001 input, the surface elevation of Lake Powell was 3,609 feet above sea level. So given the year 2001, the output was 3,609. Determine the rate of change in this situation. Okay, which is just finding our slope, our m. So m is equal to, I need to label these, x sub 1, y sub 1, x sub 2, y sub 2. So our rate of change is, y sub 2 is 3,609 minus 3,843. Before we even start this, if you just look at this situation, they aren't telling us if it's increasing or decreasing. But you can see in 1998 what the sea level, what the feet was above sea level for Lake Powell, and notice that it was higher than 3 years later. 3 years later, it's less. So it's decreasing, which tells us our answer is going to be a negative rate of change because it's going down. Okay. So divided by x sub 2, which is 2001, minus 1998. All right, this one I don't remember. I'm going to go about my calculator. Hold on just a second. All right, so 3609 minus 3843 is equal to negative 234. So come on, get over there. Negative 234 divided by 2001 minus 1998 is 3 years. So what does that equal? Calculate it back. So that's divided by 3 is negative 78. So negative 78. All right. This part is important. You need to understand the verbiage, the wording to be used in your sentence, because they wanted us to determine the rate of change in this situation. All right. And you're going to want to talk about what's truly happening. You're not going to say the rate of change is, I mean, you could, but it's not really discussing what's happening. I'm going to say, or I could say the rate of change of the surface level. I'm not going to do that. I'm just going to throw the rate of change in here. The rate of change in the surface level, surface elevation of Lake Powell is, I am not going to write negative 78 feet per year because that's inappropriate conversation. You're not going to say minus 78 per year. You're going to say either increasing or decreasing. Keep it simple. If you want to come up with a different word that means increasing or decreasing, that's fine. Going up, going down, that's fine. But if you just use this language, you're not going to have any problems or issues or me questioning anything that you're saying. So the rate of change in the surface elevation of Lake Powell is decreasing, not decreasing by negative 78. The decreasing word is taking the place of the negative. So do not put decreasing by negative 78. So is decreasing, because that would be wrong. It's a double negative. Decreasing by 78, here comes our units, feet, and here comes our time per year. That would be your answer. Okay. I'm going to stop the video and come back with another one.